All right, honors chemistry. So we're going to continue. This is part 2 of the answers video for lesson 11 on Avogadro's number. And let's just go through. There's 3 problems remaining. One is sugar here, sucrose. The next one, it says optional, and that's for methane. You can get some extra credit for that. And then the final one, which is not optional, it's required, is NH3. So this is a required problem, is NH3. Okay, so let's go ahead and do this for C6H12O6. So I'm going to fill out the table. You go ahead and do it likewise, and when you come back, see how yours compares to mine. All right, so this is the table. See if how yours matches with mine. So C6H12O6, you have 3 different elements involved, C, H, and O. 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen produce 1 molecule of C6H12O6. The masses are 6 times 12.01 for carbon. You get that off your periodic table, and that gives you 72.06. AMU. For hydrogen, it's 12 times 1.01. You get that off your periodic table, and that gives you 12.12 atomic mass units. And oxygen, it's 6 times 16, and that's 96 atomic mass units. When you add up those 3 masses, you get 180.18 atomic mass units for 1 molecule of sucrose. Number of moles is exactly the same. What we're doing is taking this number and multiplying it by 6.022 times 10 to the 23rd. So these 2 things translate over into these 2 right there. So number of moles, you're multiplying this by moles, so that's a mole, that's 6 moles. Multiplying this by a mole, that's 12 moles. Multiplying this by moles, that's 6 moles, and then 1 mole of the sucrose. The grams are exactly the same number as the AMU. That's the magic of this magic number. It's the only number that will turn this number of AMU into exactly the same number of grams. No other number would do that. 12.12 AMU to 12.12 grams, 96 AMU to 96 grams, and 180.18 AMU to 180.18 grams. Okay. So 6 moles is simply 6 times a mole, 6.022 times 10 to the 23rd. That's how many atoms of carbon you would have. 12 times a mole, 6.022 times 10 to the 23rd, is how many atoms of hydrogen you would have. And 6 moles, 6 times 6.022 times 10 to the 23rd, is how many atoms of oxygen you would have. And all of those put together would form a single unit of 1 mole, 6.022 times 10 to the 23rd molecules of this compound. Okay, so see how yours compared with mine. Okay, so let's go ahead now and answer the questions. So how many fructose molecules in 3.1 moles of C6H12O6? So if I want in 1 mole, there's 6.022 times 10 to the 23rd fructose molecules. If I want 3.1 moles, I need 3.1 times this number. Okay, so there are 3.1 times this number of molecules in a mole. Molecules of C6H12O6 and 3.1 moles of C6H12O6. To multiply this by 3.1, you got to multiply that by 3.1. Let me go ahead and draw the box around this. Remember, everything is referenced to 1 mole of C6H12O6. So all of these numbers in here relate to 1 mole of this substance. Okay, how many grams is 4.5 moles of C6H12O6? So if I want 4.5 moles of this, then I have to multiply this by 4.5. Okay, so there are 4.5 times this number, 4.5 of this is going to be 4.5 times this, which is 810.81 grams of C6H12O6 in 4.5 moles of C6H12O6. All right, next question. How many moles of carbon in 2.2 moles of C6H12O6? So for every 1 mole of sucrose, there's 6 moles of carbon. So there's 6 times as many moles of carbon as there are moles of C6H12O6 that's going to be produced. If you want 2.2 times 2.2 moles, 2.2 times this, you got to multiply this by 2. Okay, so there are 2.2 times 6 moles of carbon in, which equals 13.2 moles of carbon in 2.2 moles of sucrose. All right, next up. How many grams of hydrogen in 1.6 moles of sucrose? So, how many grams? Okay, so now what you want to do is you're looking for grams of hydrogen. So come over to the hydrogen row and move over to the grams column. So we're interested in that number. So if we want 1.6 times instead of 1, there's 12.12 grams for every 1 mole. So if we want 1.6 times this, we have to multiply 1.6 times this, and that'll tell us how many grams of hydrogen in 1.6 moles of C6H12O6. All right, so there are 1.6 times 12.02, 1.6 times this number, grams of hydrogen, which is 19.4 grams of hydrogen in 1.6 moles of C6H12O6. Next question. How many oxygen atoms in 2.5 moles of C6H12O6? We'll come back. In 1 mole, we go to oxygen. This tells us how many oxygen atoms. In 1 mole, there's 6 times 6.022 times 10 to the 23rd. That's because there's 6 moles for every 1 mole, 6 moles of oxygen for every 1 mole of C6H12O6. So that means there's 6 times a mole of atoms. Now, they're asking about 2.5. If I multiply this by 2.5, I have to multiply this entire number, including the 6, everything, by 2.5. Okay, so we're going to show that, and do show the calculation how you got there, okay? Okay, so there's 2.5. You want 2.5 moles of sugar here, sucrose. You need, then the number of atoms of oxygen is going to be 2.5 times the number of atoms that are in 1 mole. So 2.5 times this is how many atoms of oxygen are in 1 mole of C6H12O6. There's a mole times 6, so there's 6 times as much oxygen, at 6 times as many moles of oxygen as there are moles of sucrose. If we multiply that by 2.5, then you've got to multiply the atoms of oxygen by 2.5, and that's how many atoms of oxygen are in 1 mole. So that times 2.5. All right, so this whole calculation, let me go ahead and give you that number. So we're going to go ahead and 2.5, I didn't do this in the past problems, times 6 times 6.022 equals 90.33. So these coefficients multiply to be 90.33. I'm going to make that number smaller and make it 9.03. So I made that number smaller, the coefficient smaller, so I have to make the exponent bigger. So times 10 to the 24. Again, those three multiplied would be 90.33 times 10 to the 23rd. I move the decimal over and make it 9.03. That means I made this smaller, so I have to make the exponent bigger, and that would be atoms of oxygen. So that's how many there would be. Okay, finally, how many grams of hydrogen in 4.4 moles of C6H12O6? So we come back here. So in 1 mole of C6H12O6, there are 12.12 grams of hydrogen. So if I'm interested in 4.4 moles of this, that's 4.4 times this. I have to multiply this by 4.4. Okay, so there's 4.4 times 12.12 grams. This is how many grams in 1 mole of sucrose. So there's 4.4 times that many grams in 4.4 moles of sucrose. Okay, and that takes care of that problem. All right, I am going to go ahead and I'm going to leave the last two for you. And we might do these in class. But I want you to do these on your own. You should be able to with the first 3 examples of this. So again, CH4 is optional, but I'll give 25 points for doing that because I want you to practice these. Be sure you understand this concept. If you get it, I don't want to make you do this if you feel like it makes sense totally. But if you need some practice, there's an extra problem for 25 points. And then NH3 is required. So this one is required. I just happened to put it at the end rather than before the optional problem, but it is required to do that, okay? So fill out the table, do everything we did in the previous problems, and write the sentences out the way that I showed you, and it's always after a number is units of measure and then the substance in parentheses, okay? All right, so that takes care of this lesson, and we will cover this some more in class on Friday and on Monday. So I will see you then.